So just I'll take 2 minutes what I discussed in the last class. So what is Apache Spark? Why PySpark? Need for PySpark. Need for Spark, Python when Scala, PySpark features, real life usage of PySpark, PySpark job market. Okay, what is Apache Spark? Spark is an open source distributed cluster computing framework in parallel processor style with in-memory computation feature, right, used for large-scale data processing. It is a general engine for big data analysis, for processing and computation, right? It is a very high-speed processing execution engine for processing huge data, right? For processing huge data. And why PySpark? It's a Python API to use Spark. PySpark is the Python API to use Spark. Yes. Spark is an open source cluster computing used for big data solution. PySpark is the lightning fast technology which is designed for fast computation. It is a very demanding tool among data engineers to work with the bigger data sets. PySpark used for distributed SQL, for creating a data pipelines, ingesting data into a database, running ML algorithms, right? Working with the graphs or data streams, working with the data streams, right? Need for PySpark. What is the necessity for PySpark? We have got a large amount of data is generating through offline and through online. This data contains hidden patterns, unknown corrections, market trends, customer preferences, and other useful information, right? It is necessary to extract valuable information from the raw data. We require a more efficient tool to perform different types of operations on the big data. So there are various tools to perform these multiple tasks on this huge data set, but these tools are not so appealing. So we have got some scalable and flexible tools to crack big data and gain benefit from it. So PySpark is such a kind. The combination of Python and Spark would be the very efficient for the world of big data. That's why Apache Spark community came up with a tool called PySpark. Spark with Python implementation. By default, Spark built using Scala language. Previously, Scala was used a lot, right? Scala is used a lot, right? Python and Scala, right? Python is an interpreted dynamic type, but Scala is statically typed. So Python has got a huge community. Scala community is smaller. Python supports thousands of modules. Scala is used only for Spark. Python contains powerful libraries for data science, for graphs, and for streaming. Scala has no such. PySpark main features, right? Yes. In-memory computation, but storing and processing both happening in the memory level. Lazy evaluated, executing the data flow on demand. Executing the data flow on demand. Means lazy evaluated means whenever required, then only the data flow will be executed on demand. See, whenever you define, what do you mean by active evolution? What do you mean by lazy evolution? Means whenever defined, immediately execution, that is what? Active evolution. But lazy evolution means executing the data flow only on demand whenever required by providing some action. And partitioning, Spark data is divided into partitions. Spark data is divided into multiple partitions. Those partitions are distributed across multiple slave systems. Spark has powerful fault tolerant model. Spark has powerful fault tolerant model. Immutability. Spark data objects are immutable. Spark data objects are immutable. Persistence. Reusing already executed transformation. Reusing already executed transformation output, right? So here we are reusing instead of re-executing. Yes, these are the main features, right? Mainly in-memory computation, persistence, partitioning, right? Where you will get achieve parallel processing, right? So I was discussing about real-life usage of PySpark. Okay. So before I go with the real-life usage, right? Just some history on this Spark. Evolution of Apache Spark. Evolution of Apache Spark. Spark was developed by Matei Zaharia in AMP lab, Berkeley. In the year 2009. In the year 2009. Spark was developed by Matei Zaharia in AMP lab, Berkeley in the year 2009. Spark was open sourced in the year 2010. Spark was open sourced in the year 2010. Spark was donated. Spark was donated to Apache Software Foundation. Spark was donated to Apache Software Foundation in the year 2013. Spark was donated to Apache Software Foundation in the year 2013. Yes. So defining Spark, I have already defined it is open source distributed computing parallel processing within memory used for large scale data processing. In memory means here data gets loaded into RAM, data gets processed in the RAM, right? Once again, right? In memory computation. Data gets loaded. The data gets loaded into RAM and gets processed within RAM. Loaded into RAM and get processed within RAM. Here, data divided into partitions. Data divided into partitions, and the partitions are distributed, across multiple slave machines. Multiple slave machines and are processed. Data divided into partitions. The partitions are distributed across multiple slave machines and are processed. Okay. So Spark is a general engine for big data analysis, processing computation. It is a very high-speed processing engine for processing huge data, right? So Python API to use Spark. Okay. Spark can be coded with Scala language, Python language, Java language, and R language. Scala is the default. Scala, Python, Java, and R language. Spark by default written in Scala language. Previously, Scala was used preferred a lot, but today like Spark with Python, like PySpark is preferred a lot. So I can say Scala is the native language of Spark. Execution generations. If we talk execution generations, we have got MapReduce. If we talk execution in MapReduce, Sage, Spark. We see the different technologies compared with Spark. Sage and Spark. If we talk Sage and Spark, both follows directed acyclic graphs. What is that? Both follows DAG, directed acyclic graph model. Directed acyclic graph model. Both follows DAG, directed acyclic graph model, right? Sage doesn't follow in-memory computation. Sage doesn't follow in-memory computation, but Spark is a in-memory computation system. Sage doesn't follow in-memory computation, but Spark is a in-memory computation system. So Spark has got high speed. Spark has very high speed as compared to Sage. So both, if you talk about this, both the technologies, the commonality what you observe is both follows DAG, directed acyclic graph model, right? Spark has very high speed as compared to Sage. We talk about other in-memory computation systems. Other in-memory computation in the market. HANA. Other in-memory computation systems in the market. HANA. HANA and Spark. Just check now. HANA and Spark. Both follows in-memory. Both follows in-memory computation. HANA is not distributed. HANA and Spark both follows in-memory computation. HANA is not distributed, but Spark is distributed. Distributed RAM. So when compared with Tej, both are DAG, both follows directed acyclic graph, but Tej doesn't follow in-memory. Spark follows in-memory. HANA is not distributed. Spark is distributed. So generally, so for huge storage, so previously we has got Hadoop both for processing, for storage and processing. So for huge storage, for fast processing, we go for Spark. Combinedly, both can store and process huge data. Combinedly, both can store and process huge data. Spark is mainly designed for batch applications. There are two types of applications: online applications and batch applications. Batch applications means, see, online applications means user interactive applications. User has to give the input. You will get the response. User interactive applications. 。 . 。 . 。 . 。 . . 。 . . . 。 . . . . . . . . . . . . . . . . . . . . . . . . . . . . 。 。 . . . 。 。 . . . . 。 . 。 . . . User interactive applications that to here millions and trillions of records or transactions involved. And Spark is mainly designed for iterative algorithms. Iterative algorithms means right. Most of the ML machine learning algorithms are iterative, right? Yes. Interactive queries. For interactive queries. For streaming. Spark mainly designed for batch applications, interactive algorithms, iterative queries, streaming, and for graph. Okay. Spark is 100 times faster. Spark is 100 times faster. Normal disk processing. Normal disk processing. There was a test. There was a test conducted right by Yahoo. Yeah, example, right? As you can see, Yahoo has conducted a test. Yahoo has taken a table. It has taken a table of 100 TB consisting of 1024 columns. Task sorting. What was the task? Sorting. Sorting based on 16 columns. Spark is 100 times faster. It has taken it. Okay. Yahoo has taken a table of 100 TB consisting of 1024 columns. Task sorting based on 16 columns. Sorting based on 16 columns, right? Yes. Sorting based on 16 columns. So what is the time taken, right? Different things. Time taken. Time taken by different databases. Time taken by Oracle. First Oracle, right? Yes. Around it will take around 6 days. It has taken, okay. So 1 second. MySQL has taken 6 days. Sorry. Oracle has taken 3.5 days. Teradata, a specialized database used for data warehouse, right? What is Teradata? It has just taken 4.5 hours, right? 4.5 hours. Teradata is a specialized database used for data warehouse purpose. It has just taken 4.4. Another database used for data warehouse, Netija. If you heard about this, Netija, another specialized database used for data warehouse. It has just taken 3 hours. Finally, Hadoop, big data Hadoop, has just taken 3.4 minutes. Has taken 3.4 minutes. So these have taken days of time. These have taken hours of time. It has taken only minutes of time. It has taken minutes of time. But already it has taken very less time, right? It has taken very less time. But Spark is 100 times faster. Spark is 100 times faster. faster than Hadoop. 100 times. Spark is 100 times faster than Hadoop. This is why the motivation towards Spark, because of its very high speed. Hadoop and Spark. If we talk about Hadoop and Spark, in Hadoop we have got map reduce execution, right? In Hadoop, we have map reduce execution model. In Hadoop, we have map reduce execution model. Map reduce drawbacks. First thing, transformations cannot be reused. Transformations cannot be reused. So we need to re-execute every time. And this is bad for iterative algorithms, not bad for iterative algorithms. Not a flexible parallel process. Not a flexible parallel process. Transformations cannot be reused. Bad for iterative algorithms, not a flexible parallel process. Slow processing as compared to Spark. So map reduce. So it is not a flexible parallel process means first mapper phase, next reducer phase. Two phases are there. One after the other, they'll be executing. But map reduce is designed in such a way that they need to execute parallelly. But mapper first executes, next reducer executes, one after the other sequentially. That's why I'm saying not a flexible parallel process. Bad for iterative algorithms. Most of these ML algorithms are iterative in nature. So Spark and Apache pick. Spark and Apache pick. Spark and Apache pick, right? Apache Spark and Apache pick. The commonality what you see between these, both are data flow languages. What is that? Both are data flow languages. Both are data flow languages. Pig is a processing component of Hadoop. Both Spark and Pig are data flow, but in Pig, entire data flow is converted. One MR job, one map reduce job. But in Pig, the entire data flow is converted into one map reduce job. One map reduce job. But again, map reduce is bad. Map reduce is bad. Spark and Flink. Spark and Flink, right? Yes. Both are Apache products. Both purpose and objective. Both purpose and objective is same. Both purpose and objective is same. Both are Apache products. Both purpose and objective is same. Okay, in the earlier stages, right, whenever Spark was introduced, after Spark, Flink was introduced by Apache, there was a talk, right? Flink is dominating Spark and people started migrating to Flink. They are saying that Spark will be away from the market. Yes, it was real, right? Flink was dominating Spark. In the earlier versions, of Spark, Spark was weaker. Spark was weaker in terms of in the earlier versions of Spark, Spark was weaker in terms of analytics. In terms of machine learning. In terms of machine learning. Spark was weaker in terms of machine learning. But in versions, but from Spark 1.6, version, Spark introduced powerful libraries. Powerful libraries for data analytics. Streaming, graphs, etc. Before Spark 1.6, before Spark 1.6 version, Spark was weaker as compared to Flink. From Spark 1.6. From Spark 1.6, right? Yes. Spark equal to Flink. From Spark 2.0, Spark is from Spark 1.6, Spark from Spark 1.6, Spark equal to Flink. From Spark 2.0, Spark was dominating Flink. Again, Flink is away from the market. You can see Spark. So if we just enumerate Spark features and advantages. Spark features and advantages. First thing is in-memory computation. In-memory computation to very high speed because of in-memory computation, which you are not able to see in Tej. Secondly, distributed execution. Distributed execution, which you are not able to see in HANA. HANA. Next, flexible parallel process. Flexible parallel process, which you are not able to see in MapReduce, Hadoop MapReduce. Very high speed. Very high speed. Multi-language support. Multi-language support. Very high speed. In-memory computation, distributed execution, flexible parallel process, very high speed, multi-language support. Good for iterative algorithms. Good for iterative algorithms. Supports advanced analytics. Transformations can be reused. So distributed in-memory computation, transformations can be used. Parallel processing. In-memory computation, distributed execution, flexible parallel process, already we have said, very high speed, multi-language support, good for iterative algorithms. Supports advanced analytics, transformations can be reused, right? So this is just briefing you about this Spark. Spark today has got great boom in today's market, right? Yes. Even the PySpark, Spark with Python, as Python has got many libraries. Python has got many libraries towards machine learning and other things, right? 89,300 modules Python is providing. That's why we are choosing Python as an implementation language. Spark can be implemented in multiple languages. But yes. One second. So even if you see the salary package also for this PySpark, 1.5 times more than any other technologies, it has got a great demand for this PySpark. Very high speed processing, which processes huge data at quick time. Yes. So it is providing many inbuilt functionalities, many functions provided for performing this. But so So if you see year by year, lot of if you see the increase in the job opportunities for this PySpark developers, that is data engineers. So and they also, I said, data engineers have got the highest average salary as closely as this data scientist. The two highest paying jobs, right? Data engineers and data scientists, they have got highest paying jobs. Even if you see a lot of companies like Facebook, Intel, Microsoft, all these are interested in hiring data engineers with great salary packages. Even the tech giants, including Google, Apple, Cognizant, Walmart, all are offering high paying jobs to data engineers. Hence, pursuing a data engineering career will never let you down. So it looks very simple only. So you got lot of functionalities. built-in functions in PySpark that you need to understand. So yes, just check with this. Real life usage of PySpark are mostly used in the commercial sector, in bank and financial fields, in healthcare, in predicting the patients who are going to face the issue. And even entertainment industry like Netflix today is using a PySpark for trade and e-commerce, for advertising and for recommendations. Tourism industry for giving advices to millions of customers. Yes. So we are going to discuss PySpark core programming, PySpark SQL, PySpark MLIP, and PySpark streaming. You will be getting each and every session video, soft copy of this class notes, assignments and task to work, a WhatsApp group for technical discussions. If you got any errors, you can just take snap and post that errors in the group, and resumes and interview questions, interactive and hands-on sessions. Even you can do the practicals along with me parallelly. And so just check with the course content, right? Yes. So you can see brief, patches Spark, need for PySpark, PySpark session, PySpark the context, parallelizing broadcast variables, RTD computations, persistence options, core computations, different ways of creating RTD, groupings and aggregations, various actions and transformations, inbuilt actions, PySpark SQL data frame, by creating data frame, creating an empty data frame, row class, collect with column renamed, where, filter, drop, order by, sort, join, union on UDF, flat map, PySpark SQL functions, aggregate functions, window functions, date and timestamp, JSON functions, reading and writing JSON file, when expr, lit, split, concat, translate to overlay, to date format, date diff, explode array contains array, collect list, create map keys, map values, count distinct, percent rank, type lit from to JSON, get JSON object, PySpark external sources, working with SQL statements, Spark and Hive integration, Spark and MySQL, working with CSV JSON, right? Narrow and wide transformations, handling new rows, dropping rows, handling nulls, deployment modes, local mode, cluster modes, PySpark applications, states and task drivers and executors, building Spark applications, deploying Spark applications to cluster and tuning, performance tuning, right? PySpark streaming, integration with Kafka, and PySpark machine learning, right? This is what in brief, in depth, we'll be discussing around 8 weekends, right? The course goes for around 8 to 10 weekends. So Saturday 2 hours, Sunday 2 hours, right? Okay. So any queries you got for so next week, we'll be starting with the actual things, right? We'll be entering into the technical. So next, try to get enrolled. So next week, the link will be changing. A new link, a paid link you'll be getting. So get enrolled for getting the new link. That is the paid link. So you'll be for getting the videos, notes for adding to the WhatsApp group. So just to get enrolled in the chart, you can see a big message by this online team, the course content details, their contact details, right? You can see yesterday demo video. If anyone missed yesterday's video, right? Yesterday demo video is given. Contact details, the payment details, and this account details, and this pay Google Pay or Phone Pay details are given. And if you are enrolling, right, don't forget to share the screenshot of your payment to that mail ID that is forwarded. Then only they'll be forwarding the link, right? So yes. Any other queries from your side, anyone? Right. Okay, that's fine. So I'm stopping for now. We'll continue next week, right? More discussion on this. Right, fine.